minus 125. You see that?
Mm-hmm.
So which math operation is minus?
Subtraction.
Subtraction. So that would be 279 minus 125. And the order does matter. Order does matter. That's with subtraction, order always matters. Okay. And the next one here, the word product, what math operation does that refer to?
Addition.
A product is multiplication.
Oh, multiplication, sorry.
Okay, and order does not matter. So you could either write 15x or x and 15, but the one on the left here is preferred. The number comes before the variable. That's really important in math. You'll see that, you know, for the rest of your life when you look at math, it'll be a number before a letter.
Okay.
Why don't you try the next one for me?
17 plus 4. So you do 17, and then the addition symbol, and then the 4.
Yes. Now it would also be correct to write 4 plus 17. Okay, because again, order does not matter for addition. Order matters for subtraction, and what we'll see in the next one, division. So there's a couple of ways to write p divided by 5. You can write the letter, the division operator, and then 5.
What I did for that problem was the p, then the line, then the 5.
That's also, there's a couple, and then you could put even p fraction bar 5.
Yeah, that's the p fraction bar 5 is the one I did.
Yeah, so this is the one you're going to see most often as you move forward in math. And for this one, order does matter. Order does matter. How about times? What math operation does that refer to?
No, the next one, 49 times 2. 49 multiplication symbol 2.
Okay, so hopefully you got that down. 149. You could put a dot 2. You could do 149 parentheses 2, 149
times 2.
Yeah, a lot of different ways to do that one. Okay, now the reason your teacher had you do this section first is because the next one, you really you have a couple of different ways that you can do it, and you're actually supposed to write 2 phrases. So let's do that for the first one there. So let me grab that here. All right, so r plus 87. You have the first one down correct. R plus 87. That's correct. The other word you can use is sum, and you would write it this way: the sum of R and 87.
Okay.
Do you have that down?
Yeah, I do.
Okay. For number 7, when you look up at the previous problems that we did, do you see another word for multiplication?
Product.
Product. So you can again say the product of 345 and 196. You can think of the second one as being formal and the first one as being informal. Have you talked about that at all in like English class?
Yeah.
Okay. All right, so for division, do you remember the other word for division? It's okay if you don't, but I'll,
No, yeah.
the quotient of.
Yeah.
So notice how they're all the blank, the
Mhm.
sum of, the product of. You could even have one for the difference of.
Okay.
476 and 28. Okay. So for 9, kind of the same thing. I guess they didn't give you a line for it, but the word you would use is the difference. The difference of. The difference of D and 5. You can also use some other words for subtraction. Sometimes they use the word less. Like it would be written this way: a variable x less 2. And that means x minus 2. Did you see that at all in class?
Yeah.
Okay, and that one's kind of the awkward one. All right, so let's jump down to 7 and 8 next. Is that okay? We can come back to the table, but I know these story problems are probably more challenging. All right, let's see here. Get this framed right. All right, could you read this question out loud for us?
Car is traveling at a speed of 55 miles per hour. You want to write an algebraic expression to show how far the car will travel in a certain number of hours. What will be your constant and your variable?
All right, so I'm going to read it, and if there's any words that you don't understand or you want me to explain, please ask. So a car is traveling at a speed of 55 miles per hour. You want to write an algebraic expression to show how far the car will travel in a certain number of hours. What will be your constant, your variable? Any words here that are unclear or anything that you don't understand about this?
No,
Okay, how about algebraic expression? Can you tell me what that means?
it's not like n plus 24 or something, but
Yes.
it's no equal sign.
So you gave me, yes, and that's actually said really well. You gave me an example of one, n plus 24. There's no equal sign. So you're going to see later on in this course equations. Equations have an equal sign. Expressions do not. Expressions make up an equation, but they're themselves not that. Okay. All right, so let's just make a quick table here. Let's go time and distance. And let's say you start out at 0, your distance is 0. But after 1 hour, how far have you gone?
Probably 55 miles.
55 miles. How about after 2 hours?
110.
110. Good. Okay. So the formula here, which is a little bit hard to come up with, but you can see that the numbers on the left are going up by the same amount each time, and the numbers on the right are going up by the same amount each time.
Yeah.
So the distance is your rate times the time. What is your rate in this problem?
55.
55. And what is your variable?
1.
Your variable.
Oh, my variable.
Yeah, what's your variable? What's changing each time?
The what is it? I know what it is. I'm trying to find words. The time.
The time. Yes, the time. So we can use the letter T for that. So the distance is 55 times T. Now we can check this by substituting in a value for T. So is 55 times 1 55? It's 55 times 1 55. Yeah. How about 55 times 2? Is that 110?
Yes.
So that works. Okay. So I guess I don't know how to answer this because there is no constant. But we could say that your variable is time. Maybe they mean that your constant is the rate. I'm not sure, actually. The question isn't written very well.
Okay.
So
All right.
so when you go to school in the morning, August, do you travel at the same speed from the entire trip from your house to the school?
Not really, but
So you might stop at a light, a stop
Yeah.
sign, you may have to slow down, speed up. Can you think of a place where you can actually drive at the same speed?
highway.
Highway, yeah, good. All right, let's take a look at number 8. This is one of those questions where they want you to figure out the mistake. Okay, so Sean evaluated the algebraic expression. Could you read that algebraic expression for us?
X divided by 4 for x equals 12.
Yeah, so the math operation is division. So it's 12 divided by 4, or the way you're going to want to start doing it, 12 over 4. What is 12 over 4? What is 12 divided by 4?
Total for 4. No.
So it's really asking how many times does 4 go into 12?
3.
Yeah, so you can always rewrite a division problem as that, as 4 times some number equals 12. So yeah, it's 3. Okay, so that's the correct answer. The correct answer is 12 divided by 4 is 3. I actually have, so how do you think he came up with 8? How do you get 8 from 12 and 4?
Well, I don't know. Maybe,
Like, did he add the numbers to get 8?
well, 12 plus 4 would be 16. Divide that by 2 would be 8, I guess.
Okay. So I think what they're trying to get you to do here is see that the division operator, I guess, looks a little bit like a subtraction operator.
Ah,
Sometimes it's hard to figure out what's going on when someone makes a mistake. I mean, that's sort of the core problem is they made a mistake, so they probably didn't understand to begin with what was going on. Any questions on this?
no.
Okay. I'd like us to look next at table 4 on the previous page. Is that okay? Or I guess it's the same page. How are you doing on your rocket math?
I'm doing pretty good, I guess.
Do you do the online games?
Yeah, I do.
That's great. I actually recommended it to another student, so I'm hoping that they try it out. Okay, so could you read this on the right and out loud? Like, what is the math operation going on here?
You're dividing 24 by n.
Divided by n. So for the first one, this 12 is really 24 over 2, which is 12. So for the next one, it's 24 over 6. And again, the other way you can think of this is 6 times some number equals 24.
Yeah.
I can see you're muted. Just go ahead and work out the rest of this table and I'll fill it in whenever you're ready.
Okay. All right. Now I can hear again. Okay. Four? I don't know.
You talking about for the next one? Yes, it's 4.
Mhm.
Yes, keep going. 24 over 4. Is 4 times some number is 24.
6.
Good. Go ahead and try that last one on your own, please.
3.
It is 3. Good. Okay, let's try number. I want to do number 6 next. We'll probably have time to actually do all of it, but let's. I want to make sure we get to the last page as well.
Okay.
Let's try 6. What do you see here? Tell me, kind of in your own words, what I'm.
Well,
Is that?
we're seeing how many times can n go into 2 cubed.
So I think I think you know how to do this, but the words you said wouldn't be considered correct. What are you going to do for, let's actually do n equals 4 first. What are you going to do in that?
N times 2 cubed or whatever it's called.
So it'd be 4 times 2 cubed. Now, which do you do first, the multiplication or the exponent?
Exponent.
Yes.
Would that be 8? So 4 times 8.
Yes. And what is that?
$32.
32. You got it. All right. So try it for 7 now. So that's 7 times 2 cubed or 2 to the power of 3.
So we're doing the 7 times.
Yeah, 7 times 8.
$56.
Yes.
Ten times 8 is 80.
Good.
13 times 8.
So that one you may have to work out off to the side. Now you can break apart 13 into 10 plus 3.
Is it 104?
It is 104. Good. All right, let's go to the last page and just do a couple of the average problems.
Okay. Finding the meaning.
Yeah, let's do number 3, I guess.
Mhm. That's already in order. So now let's do 8. That's 18. 18 divided by 2. Okay.
Does your instructor want you to make a sentence or anything
I
out of that?
don't know.
Okay. All right, let's have you try 5 next.
Okay. Number 5. Okay. Nine.
Yes, because you're adding them up. 5 plus 5 plus 8 over 3 this time. No, I'm sorry. You said 9, didn't you?
Yeah.
You're dividing by the number of numbers.
Oh yeah, right. Huh. Oh, that makes more sense. 6.
Yes. Okay, and so let's have you try 7 now. And, again, pay attention to the number of numbers.
Mhm.
What some students do is they actually put the number of numbers first on the bottom.
Okay. Four.
Yeah, it's 16 over 4. Oh,
Yeah.
the screen just froze up. Let that finish. Cool. Why don't you try the other one? I don't know. I don't know. Pick another one we haven't done yet, I guess.
Okay, I'll do 8.
Okay.
$15.
So what do the numbers add up to?
Oh.
They add up to 15, but what are you dividing it by?
Right, dividing it by 5. Huh.
Yes, that's the second step.
Keep forgetting to do that.
It's like, think of it like, you open your door and you get in the car, you still got to close the door. It's an important final step there to do. All right. Do you want us to finish up this page or go back to the tables on page 2?
Well, I think we can go back to the tables on page 2.
All right, let's look at number 1 first.
Okay.
And the important thing here is to figure out the order that you're going to evaluate in. What is that order? So you have n plus 8 squared. So the first one, it's 7 plus 8 squared. Do you add or do you perform the exponent first?
Exponent.
Yes. And 8 squared is always 64. So really what you're doing is n plus 64.
So like 9 plus 64, 22 plus 64. Okay.
Exactly. So if you have an exponent and a number, just evaluate it right away. And then you can do the table much faster.
71. Or sorry, no.
Let me know when you get some of these numbers down. I can start checking them.
Okay. 73.
Good. Keep going.
Okay. 31.
For the next one,
Oh wait, hang on. Oh,
you're adding it to 64.
Right, it's 64. Thought I was doing 9 plus 22. Huh. $86.
Yes.
And 35. 99.
Yes, you got it. Okay, let's look at table 2 next.
25 minus 5. 20. Oh, wait. No.
So that's why I don't like that they put the number. It's 25 minus 20, which is
5.
5. Yeah. And then the next one is 25 minus 5.
That's because like a negative number.
Yeah, no negatives in this set.
20.
Although 20, right? Good. Yep.
20. 18 minus, okay, 18 minus 25.
No, it's 25 minus
Minus
18.
18.
Yeah.
25 minus 18.
You have to do the order matters. Order matters in all these. It's like you don't put your shoes on before your socks. The order matters.
7.
7.
Right.
And the
For
last one there,
Saturday.
25 minus 9.
And 25 minus 9.
You have an answer for me on that? August, are you still with me?
Yeah, I'm trying to figure it out.
Okay. 25 minus 9. Think of it like what's 25 minus 10? It's 15.
Yeah.
But 9 is 1 less than 10.
14.
So you actually you go the other direction. You have to add 1
Oh,
back to 16.
okay.
The other way you can do it is you can look at it as 25 minus 5 minus 4.
Mm.
I don't know if that helps. That gets you to 20 minus 6 to 4, which is still 16. The other way to do it is to borrow.
Yeah.
Okay, so that's you're borrowing from there. 15 minus 9 is
Yeah.
6. I don't know, it still maybe doesn't help, but it is the correct way. So a couple problems for you to finish on your own. Probably only take you 5 or 10 minutes to finish this up, but that is it for today. So I will see you next week. I hope you have a great rest of your week and weekend.
Okay.
All right.
Thank you.
You're welcome. Bye now.
Bye.